How are we?
I still remain Mr. Ogwa, Kapara Islamic Secondary School. This morning, we'll discuss the paper 2 that will come from the compulsory part, that is the item 1. And in our discussion, we are going to discuss 2 items, and the 2 items will come from Wakisha and Jjeb. In Wakisha, the scenario was given to you already, but still I am going to read it for some clarification. That will be our item 1. Bakisha, they have said Mr. Mukasa, a farmer in Mubende, a district 150 kilometers far from Kampala, intends to start a fish farming project. The government, through the Parish Development Model PDM, provide free fish to qualified farmers. The PDM officials requires that for a farmer to qualify, they must have a pond with a surface area of at least 110 square meters. The farmer's only piece of land that he wants to use for this project is irregular in shape, and he intends to find out if it meets the official requirement. He contacted his engineer from Kampala, who is to travel by public means. The engineer left Kampala at 8:00 a.m. On his way, he noticed that it took him 1.5 hours to reach Jana town, which is 80 kilometers from Kampala. He reached Kasanda, which is 120 kilometers from Kampala, at 10:30 a.m. He is expected to reach Mbende by 12:00 p.m. before Mr. Mukasa leaves for other duties. The engineer established the surface area of the land by measuring its width at an interval of 4 meters long and 24 meters length. The measurements are shown below. So you have been given the table. Then they are saying when the official arrives, they accurately measure the area of the piece of land as 150 square meters. Mr. Mukasa would consider the engineer excellent if it had a relative error not greater than 0.02. So on the task, they are telling us that we should establish whether the engineer found Mr. Mukasa on site. So you realize that if you follow the scenario, for engineer to find Mr. Mukasa on site, meaning he should reach before 12:00 p.m. That is the according to the statement. And then on part B, basing on the engineer's estimation, did he decide whether Mr. Mukasa would qualify for the PDM fund? So for the PDM fund, meaning the area that will be got by using appropriation rule should be area that will be got should not be greater than 115 square meters, because that was the accurate measurement from the engineer. And then on part C, was the engineer work rated excellent? For the engineer work to be rated excellent, we should make sure that the relative error we are going to obtain should not be greater than 0.02. So let us start by looking at part A of our scenario. Part A, you realize that it is going to come from an application of linear interpolation and extrapolation, where they are talking about the distance that was supposed to be traveled by a person from Kampala to Bende. They have said from Kampala to Bende, the distance between these 150 kilometers, but they are moving in an interval of time. So I am going to tabulate this statement in a series form. I will start by putting a district, then in my district, I am going to put the distance, which is in kilometers. Then also after that, I am going to put at the look at the time that is given in hours for that. So we will look at this. Move from Kampala to Bende. So my first journey should be Kampala. They have said he leaves Kampala. Remember, if this person is just starting from Kampala, at this point, the distance here is 0. The distance being 0, they have said he left Kampala at 8:00 a.m. So 8:00 a.m. This one also means the time here is 0. I'm going to add another statement that will help us in showing the time given in the question. So I'm going to put here 8:00 a.m. Then from there, they have said on his way, he noticed that it took him 1.5 hours to reach Mityana town, which is 80 kilometers from Kampala. Mityana, which is a district, the kilometer is 80 kilometers, and the time took him was 1.5 hours. Meaning that when you look at the time, which is 1.5 hours, 1.5 in terms of the time is the same as 1.5 hours, because the 0.5 means the 30 minutes. So which means if I start moving from this, which is 8 a.m., I am going to add the 1 hour and 30 minutes, whereby you realize that he reached Mityana after leaving Kampala at 9:30 a.m. That is 1.5 hour. So we continue. They are saying is that, and then they are saying he reached Kasanda, which is 120 kilometers from Kampala at 10:30 a.m. Kasanda. They have said Kasanda is 120 kilometers from Kampala. At this point, I'm not going to put here 120. I am going to look at the distance between Kampala to Mityana, and then I will just add what is remaining to make 120. So you realize that this is going to give us the 40 kilometers, because if I add this plus this up to Kasanda, you have your 120, whereby you reach that point at 10:30 a.m. So 10:30 a.m. I am going to look at the difference between 10:30 and 9:30. You realize that 10:30 and 9:30, this is a difference of 1 hour. So to travel from Mityana to Kasanda, it is a difference of 1 hour. 1 hour means that he moved from Kampala to Kasanda at an interval of 2.5 hours. If you try to count from here, from 8 to 9, that is 1 hour. 9 to 10 is another hour. Then you go to the 30 minutes, which is 2.5. And then they are saying, now from here we are going to go to Bende. Bende, they have said the total distance was 150, meaning if I look at the distance covered so far from Kampala to Kasanda, we have so far already taken 120, meaning the remaining distance to reach Mubende only 30 kilometers. And they're saying this person is expected, they're saying is expected to reach Mubende at 12 at 12:00 p.m. So we are going to estimate and see if this person can reach Mubende at 12:00 p.m. That is by using what we are seeing here. It is the graph that will call for linear extrapolation. So we can look at the time. that will be obtained here. The time that will be obtained here should be a time. If I add, I have to first look at the time interval from 8:00 a.m. and this one here to obtain the time that will be taken for that person to reach Mubende. So the time interval from 8 to 12, you realize that this person is going to cover an approximate of 5 hours, because if you move from 5, this is the same as 1, 8 to 9, 9 to 10 is 2, 10 to 11 is 3, and 11 to 12 is 4. So which means time we are going to obtain here should be less than or equals to 4 hours. That is if I add to all of this. So like I said before, that we are having that. So I'm going to use linear extrapolation. So by linear extrapolation, I am going to use the distance that was given in kilometers and the time that was given in hours. I will only extract what I'm going to use. I'm going to extract from 80, that is kilometers, water, and 30. Then this is 1.5, 1, and then I'm going to let this one to be y, because this is what we are looking for. So we can use, linear interpolation and extrapolation. They use the gradient method. And for those who does not know the gradient method, we said that for gradient, ui can say y2 minus y1 divided by x2 minus x1. That will also be equals to y2 minus y1. That will be x2 minus x1. We use any of those. This is our first part. Then upper part will now act as our x. So I will start from there. I will say that if I have y minus 1.5, this 1.5 will act as the reference, meaning that it should also have 30 as 80. So this 80 will also subtract from either side, meaning we'll have the 1 now minus 1.5 upper one, then 40 minus 80 for the downer one. And this is 1.5 divided by negative 50. Then this one will be negative 0.5 divided by negative 40. Then we cross multiply because we're looking for the value of y. Times 1.5, which is positive 60, being equals to 0.5 times 40, which is 20. If I collect like that, this one goes that side. We have 40y equals to 20 minus 60, which is 40. Y equals to negative 40. Divide by negative 40, negative 40. So our y here will be 1. Remember, it was given in terms of hour. So our y here is 1 hour. So if I put here 1 hour, which is given as the y, now I'm going to add. Remember, before we said an interval of 120 kilometers between Kampala and Mubende should also be equivalent to the 4-hour drive for that person to reach at either 12:00 p.m. or before 12:00 p.m. That one there is to catch up with the person who is waiting for him at Mubende. So our time we are going to get here should be either 4 hours or should be less than 4 hours. So let us look at the time. The time here is this is 1.5 plus 1, which is 2.5. And then you realize that the person will only use an interval of 3.5 hours. 3.5 an hour, it is going to be approximately to 3.5 hour, 3.5. That's the total. You can say the total time is 3.5 hours, which is approximately to. We are going to look at 3.5 hours. That is from 8:00 a.m. This is the same as 3.5. So from 8:00 a.m. we'll move to 9, which is 1 hour. 9 to 10, which is 2 hour. 10 to 11, which is 3 hour. Which means the 3 hour, the 0.5 is the same as the 30 minutes, which is going to be 10:30. So you realize that the 3.5 hours, it is approximated to 11:30 a.m. So we go back to our scenario. In the scenario, they have said that he expected to reach before in Mubende by 12:00 p.m. If they said by, can either be less than that time or can either be exactly that time. And when you look at here, this person will reach at 11:30. So what should be our conclusion? Because they are saying establish whether the engineer found Mubende, found Mr. Mukasa on site. So our question is going to be a yes. Yes, since the engineer reached Mubende at 11:30 a.m., which is before 12:00 p.m. So we can say yes, the engineer reached since he reached Mubende before 12:00 p. He's reached Mubende before 12:00 p.m. That was our first part. That is the part A. And then we are going direct to part B. Part B, they are saying, based on the engineer's estimation, decide whether Mr. Mukasa would qualify for the PDM fund. Remember, for Mr. Mukasa to qualify for the PDM fund, for him to qualify, here they are saying that the PDM official requires for a farmer to qualify, they must have a pond with a surface area of at least 110 square meters, meaning the area of his farm should be above 110 square meters, which is given in the table you are seeing in the question. The table you are seeing in the question is calling for a trapezium rule, whereby in the trapezium rule you realize that at this point they have calculated for us. So our aim is only to go and substitute in the formula to come up with the value of the area. So I am going to write now draw in my table. So in the table that was given to you, they have given us the x that was given in meters. Then we also have the y that was also in meters. I am going to summarize this table in the way the trapezium rules go. 1, 4, that is 8, 12, 15, 20, and then the last value becomes 20, 24. This one here means that our expression was having a range between 0 and 20, 24. So if I try to take this value back into an expression, you realize that the question was asking us for the sub-interval, which is acting as the height. Our sub-interval here was 4. Because if our first value is 0, then what we add after 0 to get the next value is the same as the 4. And you realize that the 4 is the one which is adding up to give you any other value. So you have here, I will also have the division. In that case, our first value is the 3.0. Then the last value is 3.5. So meaning the other values is going to be 4.2, 5.1, so having 5.8, 5.4, then 4.6. Sum all of this. So this is 6.5. Then for the upper one, 4.2 plus 5.1 plus 5.8 plus 5.4, then plus 4.6. Here you're getting 25.1. So we are going to use this to find the area. Area, say that is the same as the formula for the trapezium rule, which is given by R H, which is the Y, the Y naught, plus the 2, which is the same as other values of Y, plus the last value. So you realize that we said before that our H was the 4. That is the interval. So I'm going to substitute. This one here, it acts as the 6.5. That is the first value and the last value. And then the middle value, we have got all of them as 25.1. So you have times, this was 4 into, this is the 6.5 plus 2 into 25.1. This is same as half. So the all of this is same as 2 into 6.5. Here we are having 25.1 times 2, which is 50.2. So plus 6.5, 10 times 2. Our area here is the same as 100.4 meters squared. 100.4 meters squared. So that is our obtained area. So we are going to go back to our conclusion. They have said, based on the engineer's estimation, decide whether Mr. Mukasa would qualify for the PDM. And we looked at sometime. We said that for someone to qualify, the surface area should be at least 110. And when you look at this one here, it is at least 110 because it's greater than that value. So part B, we are going to conclude. Therefore, we say Mr. Kasa will qualify for PDM since the area of his farm since the area of his farm is at least 113, at least 110 it was 110 meters, was at least 110 meters squared. For clarification, someone can also add it in a bracket. We can say it is 113.4 meters squared. This 113.4 meters squared is greater than 110 meters squared. This one should be greater than or equals to satisfy the condition at least. So that was a part B of Waukesha. And then part C, they are saying, was the engineer's work rated excellent? Was the engineer's work rated excellent? For the engineer's work to be rated excellent, in the last statement, they are saying that if it had a relative error not greater than 0.02, if it had a relative error not greater than 0.02. Now, let us look at the relative error. The relative error here, that is part C. We are going to have our relative error. This relative error, we are going to base on the values we are having. Basing on the values we are having, the engineer came up with his value. That was the exact value of the land, being 115 square meters, meaning that the 115 square meters becomes the true value or the true area. That is 115 meters squared. I will compare this value of the true area of the land with the new area, or you can say the approximated area, but because this is the land, so we are going to have the new area, which was the one we have obtained. That's 113.4 meters squared. Meaning that at this point in my relative error, I am going to obtain it by getting magnitude of the true area minus the new area. Then I divide by the true area. So we can have this, which is 115.115 minus 113.4 divided by 115. I'm leaving out the square meters because you realize that the square meters that will be up here will divide with the one down. So you have 115 minus 113. 115 minus 113.4. This is the 1.6 divided by 115. Our relative error divided by 115. Our relative error here is 0.01. You can say 0.014. So 0.014, that is obtained as the relative error. That value is less than 0.02. This value here is less than 0.02. So they are saying, was the engineer's work rated excellent? So meaning, we are going to say the engineer's work was rated excellent, since the relative, since it we can say it had a relative error This had a relative error of 0.014, which is less than 0.02. Can also summarize it here. You say 0.014 less than 0.0 less than 0.02. So that was it concerning the item 1. That was given as a compulsory item of Waukesha. Item 1, that was given as a compulsory item of Waukesha. Now,